Hi everyone, today we're going to be talking about topic 4.2, net ionic equations. I want to first start with a very short review just on balancing equations. If we have this combustion reaction here where methane plus oxygen, CH4 plus O2, when those react together and burn, you'll make water and CO2. And so on the left side here, we have 1 carbon, we have 4 hydrogens, and we have 2 oxygens. And on our right side here in our products, we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens. And so if we wanted to balance this, we could multiply, we can put a 2 in front of our H2O. That would get us up to 4 hydrogens and 4 oxygens total. And then on this side, all we need to do is add a 2 in front of that O2 to get us up to 4 oxygens. And so we should have 1 carbon, 4 hydrogens, and 4 oxygens. As a reminder, the start of a reaction, these are called our reactants. And afterwards, these are our products. And you always want to balance your equations with whole numbers. We don't want to be using fractions in most cases. We must remember that all reactions, all chemical reactions, must follow the law of conservation of mass, which states matter cannot be created or destroyed. Right? And so whatever you start with on your reactant side, that's what you must end with on the products. And so same number of atoms in the start and end of a reaction. Always remember that one rule. In a chemical equation, we always have to remember our chemical equation states. And so, for example, in the equation I was showing, these are all in gases. And the 4 states we'll typically encounter are gas, which is G, solid, which is S, liquid, which is L, and aqueous, which is AQ, and this is dissolved in water. Now, something that you may or may not have seen before are known as complete ionic equations. And so let's take this example here. We have barium chloride, BaCl2, aqueous, reacting with sodium sulfate, Na2SO4, again aqueous, which makes this solid barium sulfate and 2 sodium chloride. Again, this is aqueous. And so this would be known as our complete chemical equation. And for a complete ionic equation, what you're going to do is separate all ions and keep solids together. And so it's going to look like something like this for barium chloride. So on our reactant side, we would have Ba2 plus 2 Cl minus. I should add that these are both aqueous, plus 2 Na plus, aqueous, plus SO4 2 minus, aqueous. Those are our reactants. And on our product side, because this barium sulfate is a solid, this would stay as barium sulfate, BaSO4, plus 2 Na plus, aqueous, plus 2 Cl minus, again, aqueous. Now, you may be wondering, Dr. Reda, why would I want to separate all of these out? Well, of course, in a lot of reactions, we have ions that don't necessarily do anything, or we don't necessarily care about what the chemistry is happening there. And so what we can get from this is known as a net ionic equation. And in order to get this, what we do is we remove what are known as spectator ions. And these are ions that do not react. So we want to look for these spectator ions. What we need to look for are ions that are in the reactant and products side. So let's look at our spectator ions for this example here. If I look, I have chloride, right? I have 2Cl minus there, and I have 2Cl minus here. I have 2Na plus here, and I have 2Na plus right here. And so all of these are spectators. They're in solution, but they don't actually participate in the reaction that we're interested in. So what we can do for our net ionic equation is we can just cancel all of those out. And so the net ionic down here would be Ba2 plus aqueous plus SO4 2 minus aqueous makes barium sulfate, BaSO4 solid. And that's our net ionic equation. This is what we're actually interested in. All of the other ions and solutions are just spectating. They're just watching the reaction happen. Now I want to go over a few solubility rules to help you all out. The first thing you got to remember is that a precipitation reaction occurs when two solutions containing soluble salts mix to form an insoluble salt. Now, normally we see this with water, but this can, of course, happen with any other solvent. So typically you'll mix together two soluble salts and that'll make an insoluble salt. Now, here's a list of ions that are always soluble. And so if you see them, they should never exist as precipitates. These are sodium, or Na+, potassium, or K+, ammonium, or NH4+, that's one of our polyatomic ions, and nitrates, which is NO3-. If you ever see these in a reaction, these will always be soluble. You can essentially think of these as always being spectator ions in any reaction we're looking at. We'll go over a few more practice problems in class, but for now, that's all. Thanks, guys.